Hey, at this point, I'm sure all of you know what LangChain is, but do you want to be one of the first to get your hands deep in on LangGraph? I wanted to really deep dive into what exactly is going on behind this LangGraph and how are they really using graphs in order to really change how you handle LLM executions. So let's get right into it. The first thing I like to do is two things. One, understand all the files, get a good idea of what are the important files, and generate a diagram. So let's first go ahead and look at a diagram. So I'll ask it to draw a diagram of LangGraph. Now here you can see we have each of the main components, which we can take a look into and then better understand how each of the components work and which parts we want to dive further into. So here you can see there's a few main components in LangGraph. First, there is the agent executor. Okay, it looks like that might be responsible for executing the agent, orchestrating the tools, the agent, running the agent, discerning if it should continue. Then there is a chat agent executor. Perhaps that takes in some chat history. There's a pre-built tool executor that handles running tools. And then we have these other classes here. The context, which seems to be a channel. There's a checkpoint, okay, and then the memory saver seems to be a child class of the base checkpoint saver, as we can see here. It's calling this, so it's a version of that. And then here we can see there's a topic. Again, it's a channel. So it looks like both topics and context are both different types of channels. And it calls the base channel. So there's a few different things that are calling base channel here. You can see there's the topic. There's all the way up here. You can see the context is also of type base channel. The binary operator aggregate. So each of these are of type base channel. So you can try to understand better what a base channel is. And then there seems to be a few other channels. There's the binary operator. Okay, now that's channels. There seems to be another big class called graph state. So there's a state graph. We'll look into how that graph is built. And then there's this whole class called Pregal. Now I briefly skimmed the LangGraph documentation and it looks like Pregal is this actual graph library that LangGraph is working with. So we can look deeper into how Pregal works and what it's doing. So it looks like Pregal read has two main functions, channel batch and channel invoke. And those call channel read, which has a few async functions. Then there's channels.lastValue, channel write, and channel read. Okay, great. So now that we have this overview of what the whole LangGraph library looks like, we can break down each of these different components to understand better the state graph, the agent executor, channels, the differences between topics and context, and then how the Pregal graph works with the read, the write, and how it works with channels and the agent executor and all of that. So now that we have this idea of what we're looking at, let's really dive deep into each of these different components. So as we can see, here's a high-level file path of the directory. And you can see that there's examples. This walks us through the main examples we can take a look at. There's channels. So now channels, as we saw, there's a few main channels. There seems to be a topic, a context channel, a base, and a binary operator aggregate. All right. So we can look into these in more detail. It looks like the context channel defines a class called context that exposes the value of a context manager for the duration of an invocation, provides functionality for entering and exiting the context manager, as well as retrieving the stored value. The topic represents a configurable pub subtopic. It has functionality for updating the topic with values, getting the current values, and creating a checkpoint of the topic state. A checkpoint is, okay, so memory seems to be is a type of checkpoint. So this file defines a class called memory saver that extends base checkpoint saver and provides functionality for storing and retrieving checkpoints in a dictionary. All right, so that's kind of how the channels and the checkpoints and the memory work. We can dive deeper into those in a minute. Then you have the graph, which contains the implementation of the Pregal algorithm, which is a parallel graph processing model, and it includes functionality for subscribing to channels, writing to channels, and executing the Pregal algorithm in both synchronous and asynchronous modes. All right, so let's really dive deeper into what Pregal is doing as well. Okay, so now let's just go into each of these different components. So I'll ask it first.